In this video, we are going to look at the basics for testing a claim about a proportion. So we're going to talk about going through a hypothesis test in order to look at a claim that maybe the proportion is bigger than some value, or less than some value, or equal to some value, or not equal to some value. So we'll look at testing claims of those sort. For claims about proportions, we have the test statistic is a z-value. It's a z-statistic. The way that we find that z-statistic, we have our sample proportion, and from that sample proportion, we subtract the hypothesized proportion, right? So what is the proportion in the null hypothesis? Remember that null hypothesis is always that you have a population parameter equals some value. So what is that value that you are claiming in the null hypothesis that it equals? And then you divide that difference by the square root of that hypothesized p-value or proportion times the complement of that hypothesized proportion divided by the sample size. Right. So that's how we would calculate the test statistic. If we have a significance level of alpha, the critical values are going to be these z-values. And they can be calculated using techniques from Chapter 6, right, back when we talked about how do we calculate critical values. Right. So we looked at those things again in Chapter 7, so you can look back at those videos too as well. So if we want to use StatDisk to calculate this, really here is the process, the procedure that we will need to go through, or that we would want to go through. So first we want to identify both the null and the alternative hypothesis. So those we will see something where it says test the claim that something is true. Then we need to make sure we can identify the significance level alpha, the claimed proportion p, that should come from your null hypothesis, should identify your sample size, and the number of observed successes in this sample. Once you've identified those, you can go to StatDisk, you can choose analysis, hypothesis test, proportion 1 sample. You input each one of those values above that we identified, and then it will output a test statistic. It will output critical value or values depending on whether or not you have a one-tailed test or a two-tailed test. It will output the p-value and an associated confidence interval. All right, so let's take a look at an example. So here's our example. When Mendel conducted his famous genetics experiment with peas, one sample of offspring had 428 green peas and 152 yellow peas. We want to use a 0.01 significance level to test the claim. All right, so we are going to test the claim. What is the claim that we are testing? We're testing the claim that under the same circumstances, 25% will be yellow. Right, so when we go through a hypothesis test, so we observe that we're going to do a hypothesis test because we are testing the claim. Our hypothesis test, we need to identify what is the claim. So our claim that is being made is that the proportion that are yellow is 25%, and we will write this as a decimal. So that's our claim. We then identify the counterclaim, right? So the opposite. If it's not true that p is equal to 0.25, what must be true? And that is, it's absolutely anything else. It's just not 0.25. Maybe it's bigger, maybe it's smaller, but the counterclaim, the opposite, would be that it's not equal to 0.25. From this, we can identify the null hypothesis and the alternative hypothesis. The alternative hypothesis will always, always, always show up as either the claim or counterclaim. It's the one that does not allow the two sides to be equal. And so in this case, we have as an alternate hypothesis, P is not equal to 0.25. The null hypothesis should always be your alternate hypothesis, just replacing that sign in the middle with an equal sign. So that's our null and alternate hypothesis. We can also identify here that the value of alpha, our significance level, is 0.01. We can identify that our sample size is all of the green P's plus all of the yellow P's. So we have 580 in total. And the number of successes, since we are looking for the proportion that will be yellow, we're considering it a success if it's yellow. And so there are 152 yellow. So we're going to take this information and we want to go over to StatDisk with it. And so let's go to StatDisk. So here in StatDisk, we are going to choose analysis. We choose now hypothesis testing because we are trying to do a hypothesis test. We want to do a hypothesis test about a proportion with one sample. So the first thing we want to do is we want to identify what is this alternative hypothesis. Right? And so we have three options. The population proportion is not equal to some claim for proportion. That is our alternative. We're saying it's our alternative hypothesis is that it's not equal to 0.25. So that's what we'll do there. Our significance level here was 0.01. The claimed proportion, the null hypothesis, said that the proportion is actually equal to 0.25. So that's just from the claim. It's coming from the null hypothesis. Our sample size was 580. And the number of successes that we had was I don't remember. Let's look back. The number of successes was 152. So we put 152 as the number of successes, and then we evaluate that. And when we evaluate that, we get all kinds of pieces of information. Right at the top, it restates the alternate hypothesis. So P is not equal to P hypothesis. The sample proportion, so the actual proportion of those in the sample that were yellow, is 0.26207. Our test statistic is 0.67125. We have our critical Z values, our plus and minus 2.57583. And we have our p-value that's given there, 0.502. Right? So let's use that p-value, 0.502. We observe that's our p-value. That's our p-value. With that p-value, what do we do? How do we make a conclusion using the p-value? We compare the p-value to the significance level, to the value of alpha. And so we observe that 0.502, the p-value is larger than our significance level. And if our p-value is larger than the significance level, if the p-value is high, the null will fly. So we fail to reject the null. Right? So we fail to reject that null hypothesis. There is not evidence, at least not sufficient evidence, that the proportion is not equal to 0.25. We're not saying that it is equal to 0.25, we're just saying we don't have enough evidence to say it's for sure not equal to 0.25. Here, with that p-value method, what we're thinking about happening is we have like this normal distribution. Do we have a one-tailed test or a two-tailed test here? Well, because we have a not equal to sign here as the alternative, this is a two-tailed test. So we have this tail over here, this tail over here. So if our information, if we happen to lie in either of those, then we would reject. In either of those tails, we would reject. The total area between those two tails, that is the significance level. So the total area between these two things is 0.01. And when we say that our p-value is 0.502, what we're really saying is we have some test statistic. With that test statistic, we end up with something like between those two pieces, we have 50%, 0.502. And since that percent that is in those two tails exceeds the percent in the tails of rejection, we fail to reject the null. Now we could go through this in another fashion. We could say, let's use a critical value method. So let's go back to StatDisk. It told us a critical value. Our critical value, we have two critical values, plus and minus 2.576. Right? So our critical values, they are z-values. They are positive and negative 2.576. For a normal distribution, what we should imagine for this is we have this normal distribution. Somewhere up here is positive 2.576. Down here we have negative 2.576. And really, again, we're still thinking about, are we in one of these two tails? And what we want to look at is we want to look at the test statistic. So let's go back to StatDisk. Our test statistic is shown there, 0.67125. So 0.671 is the test statistic. That value of 0.671, it would be somewhere like right about here. Notice that that test statistic, it does not fall in one of those two tails. It does not exceed those critical values. So again, we fail to reject the null. So we're only going to reject this if we happen to live in that tail. So our critical value did not exceed the test statistic. Our test statistic was between the two critical values. So we fail to reject the null. These two conclusions, they should be the same. A third method that we could use is we could use a confidence interval method. So let's go back to StatDisk. There at the bottom, we have a confidence interval that is associated with this. So we have 0.215 to 0.309. And what we want to ask here is, does the hypothesized value, does the value from the null hypothesis, p equals 0.25, does that live in this interval? Since 0.25 lives in this interval, we cannot reject that. We don't have evidence of the alternative. So we fail to reject the null. It is reasonable to believe 0.25. There's a bunch of values that, based on this particular sample, would be reasonable to believe, but 0.25 is one of those. So we, again, fail to reject the null. Since the hypothesized value, the null hypothesized value, that 0.25, is in the confidence interval. So those are the three different ways we could go through and make the conclusion. Those three conclusions should always match up with each other. If you're saying we're rejecting in one place and failing to reject in the other, then in some place you have done the wrong thing. All right, we'll take a look at another example in our next video.